In this video, we'll see how we can read and print variables of built-in data types in C++ programming language. Though we have already seen how to make use of cout and cin in one of the initial videos on C++, let us have a recapitulation. Just let's revisit it. So printing using cout, they use cout like this. This is the syntax. Insertion operator, that is the two less than symbols one after the other, and then variable or character string. So example is, you will write cout, insertion operator, abc, semicolon, semicolon being the statement terminator. And abc must be a variable of some data type, may be built-in or may not be built-in. If it is built-in data type, then we need not to overload this operator. Operator overloading we will discuss in some future video. Now, reading using cin, use cin extraction operator, two greater than symbols one after the other without any space between them, and then the variable. Now, unlike C does not require to mention the data type of the variable to be used for reading from the standard input device by default in C++, which is a keyboard. No address to be supplied. C is smart enough to deduce the address and type of the variable which is being read. Example, cin extraction operator and abc semicolon. Abc is name of some variable of some data type. Okay. Now remember, there is no formatting character. There are no formatting characters unlike C. It is unlike C. In C, we used to have formatting characters to print in what format it is to be printed, how many, whether it is a bool. Bool is not supported, of course, in C, but C++ supports bool, etc. So whether it is a float type or long double or double. So let us have a look at a small program which I have made on the right hand side. The source code is there. So now you can see here we have to hash include IO_manip, and for set precision and set W, which I have used, we have to hash include the IO_manip. It has nothing to do with the built-in data type. It sets the precision, that is the number of digits after decimal point, and how much amount of space to occupy on the monitor or default output device. So on the left hand side, I will just execute it. And let me first write 5555. I will just explain later. Now here, this is the namespace std, that is standard namespace. If we don't make use of this line, as I have told you in one of the earlier videos, then everywhere, whether it is cout or cin or set precision, set W, etc., we need to write std scope resolution operator. So this is the common practice, and don't bother about this function void which I have written here. I have already developed my own library in which I have defined this function. Later we'll discuss in one of the videos how we can develop our own library for code reuse. So now here, this is unsigned num or unsigned int equal to 0b. This is the way we write binary numbers. So I can assign a binary number to an integer. Of course, binary numbers are integers. Here I have used unsigned num. 0b. Then following b, we must have only binary digits. So 101 is 5. So when I print it, cout num, it prints 5 here. Now using 0xab, I can use uppercase letter x also, lowercase also. So here uppercase or lowercase or combination thereof. So here 0x means hexadecimal, but still it is unsigned number, unsigned int. So 0xab means base is 16. In hexadecimal, capital A has a value of 10. So shifted towards left hand side by 1, so multiplied by 16, so it is 160. B is 11, so 171. So now when I say C out, but here I will say set W7. It means use 7 columns or spaces on the monitor and then print in those 7 columns. You print the number, and by default it is right justified. Starting from the right hand side, it will count these places. So now you can see here it is 171, but these are the total 7 columns, 7 spaces, out of which rightmost 3 have been occupied by 171, and leading characters are all space, because width of 171 is nothing but 3 characters. It occupies 3 characters, so leading 4 spaces it will leave. Next one is, if I say C out set W7, again 7, but now I will say hex uppercase, then num, then space. It means the cursor will not, after printing this value, cursor will not go to the next line. Actually it will leave 1 space after printing num. So uppercase means if you are using hex, it will print it in uppercase. Now you can see here it is this one, capital AB. So there are leading 5 spaces, because A and B, they occupy 2 character positions. So it will use 7 spaces on the monitor, but start filling from right hand side, or you can say AB will occupy last 2 spaces out of these 7, followed by 1 space here. Okay, so 1 space, and then again set W hex, but no uppercase. So this same number would be printed in hexadecimal format in lowercase letters. So now you can see here it is this one. Okay, so now let me clear it. Now next one is 0111. Now num is still unsigned, but if any number has leading 0, it is treated as a number represented in octal format. Octal means base is 8. So symbols would be 0, 1, 2, 3, 4, 5, 6 and 7. So base is 8. So this is 111, 0, 1, 1, 1. It means a number which is represented in octal format. So this one will be multiplied by 8 to the power 2, that is 64. And then this is 8 multiplied by 1. So add 8, 71, and this is 1, 73. So it must print 73. You can see here. Now one thing more. When I say set W, it will be effective only for that statement. For every set W, you have to specify set W. Every C out, you have to specify set W. Now, if I say hex, then it will print in hex. But if I say uppercase, and until unless you specify or change it by making use of no uppercase, it will keep on printing in uppercase only. Okay, so it has printed 73. So here it is supposed to print 73, but C out is here, so it will print. Now one thing more, I have used DEC. Otherwise, it will keep on printing in hex only. Okay, so I have to change this specification hex to DEC for decimal. So this number would be printed in decimal format, which is I am just taking this from here. This is 73 in decimal format. Otherwise, it would have been printed 73 in hexadecimal format. Now, next data type is float. Okay, double, long double. I have assigned to these 3 variables the same value 1.3, 1.3, 1.3. Okay, so here this 1.3 in F would occupy 4 bytes, assuming that float uses in 32-bit IEEE 754 standard. Float occupies 32 bits, sorry. D occupies 8 bits and long double accordingly. We have seen this in previous video, but value remains the same. But see the output. This line produces the output in one line only. I could have printed in separate lines just to save space. I have written them in a single line. So 1.3 should print, then space, then one D, that is a double, then one space, then long double. I see here, this is the value here, 1.3. This is next 1.3, 1.3. All the three values are identical. I have assigned identical. But now the interesting part is now. If I increase the precision by default, one thing more, in C by default it keeps on printing 6 digits after decimal point. Here it's not like that. It prints only significant digits. So if after 1.3 if you have 000, it will not print. Now here set precision 14. I've said. I say okay, instead of 6 you increase the number of digits after decimal point, and set W, use 15 spaces on monitor, and by default it does the right justification, as we have already seen in case of printing in hexadecimal format. And print F, leave one space, then set precision for this 98, otherwise precision will remains 14. Then again, yeah, here you use 100, then print D, that is a double, and then set precision 98 to 98 and width 100 and print long double. Now you see these values. For first C out, you can see here it prints this one. It prints a number which is less than 1.3. As I have told you number of times in previous video also, that 1.3 is such a number which cannot be represented exactly in floating point representation, which follows IEEE 754 standard. So it is actually 2.9999 and this number. Okay. So it is left justified. It is left justified and it skips the number, prints the remaining spaces. It leaves. Now here, next one is set W. Here set precision 98. So double is printed like this. Now you can see here. Let me clear and draw again. Here, this is the value 1.3, 0000, so many 0, 4440, 892, 0985 and so on. And after 1 to 5, it has nothing to print. Now here, last one for long double. Let me again erase. Long double, this is the value. It will start from here. 1.3, so many zeros, and then this one, and you will find a 945266. Both are identical. 28, 1 to 5, and so on at 1 to 5, and remaining spaces. Okay, so now you can see here the float offers less precision, so its number is not exactly 1.3, 1.299 and so on. It cannot support more than those many digits, significant digits, whereas float and double, double and long double, they offer higher precision. Okay, now what more interesting example. In school days, we were told that up to 2 places after decimal point, value of pi is nothing but 22 divided by 7, 3.14. Let's check. So I have declared float, that is numerator 22.0, denominator 7.0. For double, numerator is 22.0, denominator 7.0. For long double, this variable name 22.0 and 7.0. Now here I will just show you where is the source code. Source code is here, these lines. Now you can see here. Okay, so as I told you, by default when we use set W, then the values are strings or numbers are printed using they are right justified in the width offered or width provided. I want to print them using left justified so that I can read and I can compare digit by digit. So cout set w left. Once you write left, all following variables will be printed using left justification. It means they will start occupying the columns from the leftmost position available. So left, then set precision 98. Next one is this one. So floating point numerator divided by floating point denominator, that is 22 by 7. Next line is identical, except I have not used left because it is already active. For next one, set w 100, double numerator of double type denum, denominator of double type ddel and l, so that the number is printed in the next line, the following number. The same thing, set w 100, and then left is already there. I need not to write it again, and then long double numerator, long double denominator, and endl. Got it? Okay. And then let us see what happens corresponding to these three. First one is, this is 3.14285, this one. After this, it stops. Okay, those many digits, significant digits. After this, it might be having zeros, so it does not print zeros. Okay, whereas in case of double, this one, it offers you more precision. So this one, second one, 3.142, this is blah blah blah, and so on, 142. You can see here, after 6 digits, here it is 0, here it has become 1, here it is 7, here it is 4. Whereas the term, the expression is same, 22 divided by 7, and different digits. It continues up to 53125, and following it must be having 0, so it has not printed. Whereas in case of the third one, long double, the values are these 3.1425857 and so on. Let me clear it. Now you can see here, this one is corresponding to 22 divided by 7 in long double. Now you can match here, 4242857857, okay, 1427. Now up to this, both are printing identical value, but after this, long double has different digits, though the expression is same, 22 divided 7. And after this, if it is not having if it is having 0 or the total width offered is exhausted, it will print nothing. Okay, now you can see here the next one. This function, as I told you, I have written this function. What does it do? It takes first argument numerator, next one denominator, and next one is number of digits after decimal point. So what does this do? Now you can see here. Here it prints even more number of digits. Here 3.142, and we know that this is a recurring 3.142857, 142857, 142857, 142857, and so on. So here 142857, 142857, and after this, you can see here 857, then it is 2, whereas it is 1. It is 3, it is 4. Now you can see here. So correct value is this one, which is produced by my the function divide written by me. We know it. You can check. Take a paper and pencil and keep on dividing 22 by 7. You will get exactly the value 3.142857, 142857, 142857, and so on. You can keep on continuing. It never terminates. Whereas in case of long double, it terminates after 1 to 5. So in case of a plain float, the values are different. In case of a double, values are different, long double different, and actually it is different. That is why I always say never rely on floating point computations, because not all numbers can be represented exactly. Now come to the next line. This one, this one. Next data type is this one, char. So I have assigned 65, as I told you. Char is nothing but 1 byte integer. It can be treated as 1 byte integer. So data type is char, so it will be treated as character. So 65, I know that it is the ASCII code of capital A. So now in this line, if you can see here, see here, cout character equal to ch, it will be printed as ch, that is the character. So it has to print capital A, then followed by one comma, then space, then this string integer equal to this, and then followed by ch. Here we call it typecasting. Typecasting we will discuss in more detail in separate video. So here ch, take the value and treat it as an integer. This is what it wants to say. Though it is declared as character, but whatever it contains, treat it as integer. This is what it means. So now you can see here in this line. In this line, you can see here character equal to A, integer equal to 65. Though I declared char A, char ch was defined, declared as character, but we assigned a numerical value, and by default it will be treated as character, but we can make it behave like an integer, single byte integer. And if it is a single byte integer, it can take part in any of the arithmetic operations. So now next statement, cout ch plus 2. So ch plus 2, what is that? Ch plus 2, what is that? 67. Okay, 67. I added. So it is being treated as an integer. So it is printing an integer. Now let me check. Sorry, this line. Okay, now next one is, let me do it here. Yeah, this statement, int dc equal to 65. So here it is being treated as it is declared as an integer, value assigned is 65. Okay, now cout dc, so it will print an integer 65. Leave one space, so it prints one space here, you can see on the left hand side. And here it is integer, but I am asking it to print it as character. So this following output would be capital A. Okay. Now next, these four statements: short s equal to 5, id equal to 5, long int 5, long int 5. So they will occupy different number of bytes, and I can print all of them. Now you can see that within double quotes I have written a comma, so it will print that also. So first it will print short, then int, then long int, and then long int. So these are the values separated by comma. Okay, now this is statement type short int, long int, and long int. So it prints this string, and in response to the cin, you can read more than one variable values using single cin. Just like cout, we can print more than one variable values in single cout. So we can do with cin. And remember, whenever you keep on typing in response to cin, the reading terminates on white space characters, that is tab, space, or enter, or that is new line. So here it is short, then it will read id, that is integer int, long int, and long int. Okay, so here is the output corresponding to these. Here I typed 4 values, 5 space 5 space 5 space 5. It has printed like this. Okay. Now next one is bool. So for bool, we just declare bool tr equal to true, fl equal to false. I have assigned, I have declared two assignments in single statement. Both are of type boolean. Then if I say cout bool alpha, if I say bool alpha, all following outputs corresponding to bool will use the words true and false, all lowercase. So you can see here tr, then space value of fl. So let's see what it is do. True and false. Now I would suppress it. Cout no bool alpha. So now it will print 1 corresponding to true and 0 corresponding to false. So you can see here 1 followed by 0, the space. Now since internal representation of all boolean variables is numerical, that is true is represented as 1, false is represented as 0, so they can take part in any arithmetic operation. So here tr is 1, okay, value of tr was assigned as the it was assigned true, so 1 plus 7, it should print 8. You can see here it has printed 8. Now just like int short, int long, long, it is unsigned short us, unsigned long ul, and then unsigned long this ull. Okay, so again type in 4 values. Okay, type in 4 values us, num, ul, ull, which I typed here. It again prints the same values. Okay, now comes the numerical value like float in exponential format and fixed format. So if I declare fnum, I have already declared, okay, float, dnum, a double and ldnum, long double. I have assigned 3 values. This is 0.1 e, lowercase e or uppercase e, whatever you want to make use of, you can use. So this is the way some number, decimal point 1 or some digits e 2. Here it means 10 to the power 2. So 0.1 multiplied by 10 to the power 2. Here 0.1 multiplied by 10 to the power minus 2. Here it is 0.52 multiplied by 10 to the power 2. So when we say we want to print, so fix the precision to 6 suppose, okay, and then say scientific. I want to print in exponential format, scientific notation. So all these 3. So let me show you. All 3 I have this one, comma, uppercase. Intentionally before printing the last value I have used uppercase. It does not mean that here it was e, so you have to use e. No, it will print lowercase e for first 2 and uppercase for last one. Okay, cout. Now you can see here cout, this one. We have printed the in scientific notation. Now since I have set it to be scientific, all following couts with respect to floating point numbers or double or long double, it will use floating point representation, that is scientific printing. It means some number multiplied by 10 to the power 2 or 3 or whatever number. Now suppose I want to go back to fixed notation, it is nothing but you just use fixed, fixed, cout, fixed, and same variable names. So now here you can see they have been printed using fixed notation. So here it is 0.1 multiplied by 10 to the power 2. How much it is? It is 10.000 because I have fixed the precision to 6. So after decimal point it will print 6 digits. Here what was the value? 0.1 multiplied by 10 to the power minus 2. So it is the value corresponding to this this one, 0.001000. And last one, 0.52 multiplied by 10 to the power 2. In fixed, what is it? 52.6 zeros. Okay, so this is the way in which we can make use of various variables. We can read using cin from standard input device, which is by default keyboard, and we can print the values in various formats on the onto the default output device, which is nothing but the monitor. That is all in this video. Thank you.